Okay, this was 360 all the way around the circle. I wanted you to calculate it from the x-axis. So we're actually 30 less than 360. So this is going to be 330. I should put the degree measure on each of these, by the way. And then the next one is going to be 45 less than 360.
No, 225.
What? Did I mark it wrong? Yeah, 225. Thanks. 45 less than 360, I want you to think of it that way, which is going to be what? 315. And then 60 less than 360, which would then be 300 degrees. Okay? All right, those are the angle measures. We're not going to do the second version of it. We could go through and do a bunch of coterminal angles, right? We could go to here, 360 plus 30, which would be 390, right? Instead of 360, we could write it 0, right? Or 720. You can keep going, 360 plus 45. You can write what that is, okay? Does that make sense? Coterminal angles. You're going to get used to seeing this. You're going to have to mark all these degree measures. You're also going to have to mark that with radians after we talk about what a radian is. Cool? Okay. One, a radian is a different unit of measure. You need to remember that. It's a different way to measure angles. Two, you need to remember that all the way around a circle, when an angle is opened up all the way, when the terminal side is the same as the initial side, that is one of two measures, 0 radians or 2 pi radians. Okay? That's what you need to remember from that whole conversation we just had. Does that make sense? It's a lot simpler than the conversation we just had. All right, but what you also need to remember is you need to start filling in this unit circle with the measurements of those angles, okay? So if all the way around on an angle that's opened up all the way back to the initial point, if all the way around the circle is 2 pi, what would halfway around the circle be? 1 pi, right? So this angle from here to here is going to be 1 pi, right? What would then, let's just pick out other ones that we might understand. What's between, if we're halfway between, open up halfway between 0 and pi radians, which would be up there. How many radians would that be? Halfway between 0 and pi. 1/2 pi, right? Does that make sense? So this opening would be 1/2 pi, or pi over 2. We okay? If we continue to open this circle and we go all the way past 1 pi, right? And we go 1/2 pi past that again, okay? How many total radians is that? It's going to be pi plus pi over 2, so it's 1.5 pi, or 3 pi over 2. All right? So that's going to get us what 0 is. That's going to get us what 90 is, what 180 is, and what 270 are in terms of radians. Any questions? Okay. Next, almost the next easiest thing is to talk about the 45s, right? So we went from 0 to 90 was to open that up. That was pi over 2. To go half that distance, which is going to be at this 45. What is half the rotation from 0 to pi over 2? What's half that? Pi over 4, or 1/2 pi divided by 2 is 1/4 pi, or pi over 4. Okay, let's check this out right here. This opening, this angle right there, that is 1/4 pi, correct? This opening, that part included with this, how many fourths pi is that? That's 2/4, right? This right here, how many fourths is that? How many fourths is that? The purple, blue, and yellow. 3/4 pi, or 3 pi over 4. And if you follow that again to halfway around the circle, you get 4/4 pi, or 1 pi. It matches. And that's important that it matches. We okay? Let's keep going with the fourths. Okay? 1/4, 2/4, 3/4, 4/4. 5/4 to there. So this opening to that is going to be 5/4 pi, or 5 pi over 4. We're going to do it again. That to there is going to be 6/4, or 3 pi over 2. Does that match? Hopefully that matches. 6/4. This is going to be 7/4 all the way to there. 7 pi over 4. And then if we finish this, go right all the way around the circle, we're going to have 8/4, which reduces to 2 pi. And that's good, right? We okay? You get where we get those? We started by going all the way around the circle, 2 pi, halfway around the circle, pi, 1/4 of the way around the circle, pi over 2. And then we got to the 45. And we chopped it up in half. All right, let's do it again. Let's do it with the 30s. Okay? From here to here, that's 1 pi. How many sets of 30 is there in that whole rotation? What is that in proportion to 1 pi? How many sections are there? There's 130, 230, 330, 4, 5, 6. There's 6 sections there, right? So this section, this initial section right here, that is 1/6 pi. That makes sense? Because between 0 and pi, there are 6 sections of those 30-degree angles. That means this right here is then 1/6 pi. Okay? That's 1/6. That's 2/6, which is pi over 3 reduced. That is 3/6. Does that reduce to 1/2 pi? That's important that that happens. 3/6. This is then 4/6, which is 2 pi over 3. Then we have 5/6. Then we have 5/6. I should write that. 5 pi over 6. Then we have 6/6, right? 7/6. We write that down because that doesn't have a label. 7 pi over 6. 8/6, right? Which is reduces to what? 4/3. 8/6. So let's do 9/6. Does that reduce to 3/2? That's important, right? 9/6. 10/6, which reduces to 5 pi over what? 5 pi over 3. Well, where were we at? 10/6. 7/6. Okay? And then, wait, 11/6, sorry, counter wrong. 11/6, and then we have 12/6, back to 2 pi. Okay? Get where we get all that mess? That was exciting. You're going to need to be able to do that. Okay? That's actually going to kind of be like your first quiz, by the way, filling this thing out. Okay. All right, next one. Let's talk about what a degree is. This is going to be awesome. So a degree is 360th around an entire circle. There's a degree. What's a degree? It's 1/360th around a circle. I don't know why they have degrees. And I remember asking that to my college professor that was going through this in calc, and he was like, I don't know, because 360 is divisible by a lot of numbers. It is. So it's a cool number, like 1, 2, 3, 4, 5, 6, 8, 9, 10. That's divisible by a lot of things. That's cool. It's kind of like, I like the number 12 because it's divisible by 3, 2, 2, and 4, and 6. That's cool. Why? I don't know. Same with 360. It's cool. Okay, that's 360. Anyways, to relate degrees and radians, right? 360 degrees equals 2 pi radians, right? We said that. We've been saying that. So what does 1 pi equal? Well, if you divide both sides of this little equation we just wrote by 2, you get pi equals 180. Pi radians is 180. We did that, didn't we? 180 degrees. Pi radians is 180 degrees. We just did that in our pictures up here, right? 180 pi, 180. They're in the same spot. That's good. Good. Okay, awesome. So let's talk about how many radians 1 degree is. Well, if you look at this equation, you want this to say 1 degree. You can divide the left side of this equation by 180 to make it 1. That makes sense? So then divide the right-hand side of the equation by 180. And you get 1 degree is equal to pi over 180. That's one of your conversion factors. Okay? 1 degree equals pi over 180 radians. That is how you go from degrees to radians. Okay? How you go from radians to degrees is the opposite. You can take this little equation we wrote, and you can make this equal 1 radian, or just 1, and if you divide it by pi, on the right-hand side of this little equation, you get 1 equals 180 degrees over pi. That's how you get from a radian to a degree. Okay. And I'll finish this video online if you need more help. Your homework is online. All you're doing is you're going to use these two conversion rates to convert the two degree measures. Sorry that we ran out of time, guys. I'll finish this video doing those problems. Okay, guys, of course, email me if you have any questions as I finish this video. Sorry we didn't get through it during class. What you need to know is to go from degrees to radians. When you're going from degrees to radians, typically a radian has a pi in it. So to convert that, we want to save the pi. So we're going to keep it in the numerator of the fraction. That's how you remember between the two formulas. If you want to go from radians to degrees, you no longer want the pi in your answer. Typically, radians have a pi in their value, and you no longer want that. So to get rid of it, to go back to degrees, multiply it by the one that's going to divide the pi out, or 180 over pi. Notice between the two formulas, they're just reciprocals of each other. Another way to remember it. So let's look at this. 120 degrees, if we're converting that into radian measure, we want the pi in it, so we're going to do pi over 180. So we're going to multiply that and just reduce that fraction. It's going to be 12 pi over 180, or 18, and that's going to reduce by 6, so it's going to be 2 pi over 3 radians. To do negative 315, we're just going to multiply it by 5 over 180, and then we're going to calculate what. That's going to be negative 7 pi over 4 when it reduces. When we turn around and we do the opposite, to go from radians to degrees, to get to degrees, we no longer want the pi in there, so we want to divide it out. So that's kind of how we remember which formula to use. So you go ahead and multiply these two. When you multiply these two, those two reduce. 6 and 180 reduces to 1 and 30, so you get 150 degrees. Got to make sure to put the degree sign in there to make sure it's consistent. And then on 7, it says we want to go from radians to degrees, but there's no pi in there to kind of indicate, oh, it's a radian. We just need to know that it is. And if it was a radian, typically has a pi in it, we want to divide out that pi. So we multiply it by 180 over pi. So we do 180 times 7, which is 1260 over pi radians. Or, oops, 1260 over pi degrees, because we converted it into degrees, even though there is a pi rub.